Good morning, calculus students. We have a warm up here. Go ahead and hit pause, try it out. All right, so let's go over this now that you had a chance to work through it. And our goal is to write the equation of the tangent line. So right away, I know that I need a point and I need a slope. And they give me the point, and then they give me dy dx. Remember, dy dx is the slope, but I need the slope at the given point. So I need the slope when x is 1 and y is 1. So all I need to do to find the slope is to actually evaluate dy dx. And sometimes you see them write it like this, where we're just going to plug in 1 times 1 squared, which is 1 squared or 1. So there's my slope. We have the slope, we have the point, and we're done. Right? We just got to plug it in. So y minus y1 times x minus x1. Well, I know my slope is 1, and the slope is only 1 at this given point of 1, 1. Now, make sure you follow the colors here. You could distribute this and solve. Honestly, I'd tell you to stop right here. Completely acceptable answer. If you went further, then you see that those values reduce out. You could have also answered with any algebraic equivalent to this. Okay, so just remember, equation for tangent line, you need a point, and dy dx is the equation for the slope. That's really important for you to understand. Okay, but it's more than just that point. You can't write the equation there. You have to use the given point, and it's the slope at that point. All right, we're going to jump into something called separable differential equations. It's a spin-off of what we did the other day. So I want you to be aware of this. And notice one of the issues we have here. The directions just say find the general solution. Well, the problem that we have is I have an x and a y on the same side. So I'm going to go through this, and maybe don't write this one down. You can if you want to, but then I'm going to give you a step-by-step process for how we think about these problems. So the first thing I want to do is I don't love that x times y is being squared. I'm just going to rewrite this, right? Because they're multiplication, it's only working because it's multiplication, is I can rewrite this as x squared times y squared. Now notice the word separable. I need to separate the x's and y's. I need dy to stay on the left side, and I need dx to move over on the right side. What that means that anything with an x is going to stay on the right, and anything with a y has to move over using algebra. So here I have times by y squared, so I'm going to divide by y squared. Notice I separated the x's from the y's. Now I'm going to find the antiderivative. So nothing crazy there. Maybe you want to rewrite y squared. Instead of 1 over y squared, I'm going to write that as y squared to the negative 2. I'm happy with x squared. And then they're both just undoing the power rule. So remember, we're going to add 1 to the top, so that'll give me y to the negative 1. But if I put a negative 1 up top, I have to multiply by the reciprocal, which is still negative 1. And if I add 1 to the 2 here, then I get x to the third. But if I put a 3 up top, I have to compensate for that and put a 3 out in front. And then we have to put a plus c. Now, you could stop here and you'd get credit, but most of the work you're going to be doing requires us to solve for y. So once you get your general solution, if y isn't by itself, you want to do whatever you can to get y by itself. So this negative 1, I'm going to divide all pieces by negative 1 first. So that'll be negative 1/3 x to the third. Now here's a tricky spot. C stands for constant. We don't know if that's constant positive or negative, so if I divide by a negative, that's not going to change c being a constant. So I'm just going to call it c. It kind of absorbed that negative. I know it's a little odd, but then we have to deal with this 1 over y. And sometimes a lot of kids get messed up on this. What do we do with this? Well, rewrite it. Right? Remember what that means. This is 1 over y. So what I'm going to do then is I need to get this in terms of y. I'm going to flip the left side, or instead of dividing by 1, I can just call that y. So I flip to the left side, and in that case, I'm going to put this all over 1, and I'm going to flip the right side as well. And there is my equation. And notice, find the general solution. General solution should be something about y equals something something plus c, and I have exactly that. Okay? If you're not sure, you can take the derivative of this, and you should get back where you started, but it wouldn't be super friendly. It would require a lot of extra work. All right, so there's my general solution. But what if I then tell you that it has an initial condition at 1, 1? Find the particular solution. So find the particular solution is when we use the value that x is 1 and y is 1. Now we're going to find c. So all I'm going to do is plug in 1 for y. And then just work around algebraically until I find c. So what do we get? We get 1 equals 1 over 1 to the third power times negative 1/3. And at this point, I would cross multiply, right? You can always make this a fraction, cross multiply, and you're going to end up with 1 equaling, so 1 times 1 is 1, and 1 times the denominator here. And then I'm just going to add 1/3 to 1, which is 4/3. So what's the particular solution? Y equals 1 over negative 1/3 x to the third plus my initial condition, 4/3. There's the particular solution. So there's the particular solution. We're actually not going to do this part right here. We're going to skip that for right now. Okay. So what did I do in that problem? I would definitely pause the video and write this here. Here are the steps for using what we call separation of variables. Your goal is to get the x's on one side and the y's on the other side. So you need to write the derivative as a differential. Now when we say differential, that's like dy dx, or maybe it's dr dt. Whatever you do, it's always going to be your independent variable on the bottom over your dependent variable up top, right? So what do we do? This is the most important part right here. You have to separate the variables. Sometimes we use algebra, sometimes it's cross multiplication. It takes experience, just an exposure to get used to how we do that. And then we integrate both sides. Remember, integrate, hopefully you're really good with that. And then don't forget the plus c on the, we usually put it on the right side. Our goal then is to solve for the y and c if possible. So those are the steps. Pause the video if you need to finish writing this down. We're going to do a couple problems and show you how separation of variable works. Okay, so let's take a look right away. Solve the differential equation, find the particular solution. We have dy dx equals y over x squared. You can see that the y's are not on the same side with dy, and the dx is not on the same side as dx. Now here's the hint. You have to keep the dy needs to be in the numerator. So this dx, see how it's in the denominator? It's going to have to move over here. So that means my x's have to be on the right-hand side. So this y has to move over. And how do we do that? We use algebra. Right? So what am I going to do? I need to get rid of a times by y. So I'm going to multiply both sides by the reciprocal. And that's usually the biggest mistake. We get 1 over y dy. So see how the y brought over, that reduces this part out. Now notice, x is still in the denominator, and then the dx is going to move over to the other side. So there it is. You'll get, usually it's 1 point for separating the x's and y's correctly. Now we have to take the antiderivatives. We have to integrate. Well, this one here, we've got the natural log of y with the absolute value bars around. That's the, whose derivative gives me 1 over y? It's ln of y. And this one, I want to just rewrite it. That I'm thinking of this as the same as x to the negative 2. So if I add 1 to it, I get a negative 1 up top, which means I'm putting a negative out front. And then I get c. Now, you could try to solve for y right now. But at this point, as soon as you integrate, as soon as you take the antiderivative, we're going to use the initial condition. And what is the initial condition? When x is negative 1, so I'm going to plug in negative 1 here, y is equal to e. And that will give me all the pieces I need to find the c value. Right? So you can see I plug it in. Now I can simplify and solve for c. So ln of e, well, those are inverse operations of each other. They're going to reduce each other out and left with a positive 1. And then I do the inverse. So I'm going to do this a little bit more work. I'm thinking this is negative 1 times negative 1 to the first power. So that's what this negative brings it down in the denominator, which is really a negative divided by a negative, or a positive 1. And then when I subtract 1 over here, I end up with c equals 0. So what do? We always go back, once you find c, you always go back to the first spot where c appeared, right here. We're going to plug 0 in. I'm going to take the natural log of y equals negative x to the negative first power plus c. What is c? C is 0. And then I just have to solve for y. Now you could do some creative algebra here, or you can just leave it, but I need to get y by itself. So plug in c equals 0, solve for y. So algebraically, I need to get y by itself. Well, to do that, I need to take the entire right side and the entire left side and raise them to the power of e. Because we know e and ln reduce each other out, and I'm left with the absolute value of y. We'll talk about that absolute value in just a second, and what's left over then is e to the negative x to the negative 1 plus 0. Now you could do this, because notice this is e to both spots. You can rewrite this as e to the 0, which is kind of an important thing. That was one of our properties we talked about in the warm-up from yesterday, or Monday. E to the 0 is 1. So that's going to go away. So that whole thing is 1. And I'm left with e to the negative x to the negative 1. So I could put a 1 out in front here. If I put this 1 here, it's representing e to the 0, but I don't need it. But a lot of students kind of ask, well, wait a minute, Strub, what happened to the absolute value bars? How do I know which value to pick? That just means that these values are going to be plus or minus. Now, there is a right one to pick. It's based off of the initial condition. So in your brain, if you take negative 1 and plug it in here, negative 1 to the negative first power is going to be a negative and a negative of a negative. So this will be positive 1. Well, the only way e is going to be a positive e is if we take the positive value. So that's kind of tough for students to think of right away. But I want you to just know the sign of this answer is based off of the initial condition. Now, there is one other way you could write this. You could write it as 1 over e to the 1x. So this negative right here brings everything in the denominator, and this negative makes the x turn into 1 over x. So it might be written this way as a multiple choice question. All right, let's try another one. This is something you will not get super comfortable with until we get really used to the process. All right, so notice the directions. Find the general solution. So right away, I don't have an initial condition, so I know my answer is going to have a plus c in it. But notice y prime. Okay? We know that y prime is the same as dy dx. And then what do I have to do? I have to separate. I need to move the y to the third over to the other side. And I do that through inverse operations, right? This is times y to the third, so I'm going to multiply by the reciprocal, or some people say divide. So what does that do? That leaves me with y to the negative third dy equals 5x squared dx. So notice the y's are all together on one side, the x's are all together on the other side. Then I'm going to take the antiderivative. But I might want to rethink how this one is written, right? 1 over y to the third is the same as y to the negative third. Well, now I can undo the power rule by adding 1. I'm taking the antiderivative, I'm going to add 1, that gives me y to the negative 2, but if I put a negative 2 up top, I have to multiply by its reciprocal. And then I'm going to do the same thing here. I'm going to add 1 up top. So the 5 is a constant. Get x to the third. If I put a 3 up top, I got to divide by a 3. Then I'm going to put the plus c. Okay. So I just separated my variables, took the antiderivatives of each. Now, the last thing is I have to solve for y. Right? Well, how do I do that? I have to move this 2. I got to times by negative 2 to both sides. So when I do that, that'll give me a negative 10 up top. Divide by 3 stays, x to the third. And then remember, this is kind of just like a new c. Some people put a 1 there just to indicate that this c is not the same as this one, but c is a constant, and that multiplication of a 2 is going to be absorbed by that constant. So you really don't need that there. If you wanted to, I guess you could keep all this in parentheses too, and then just put the 2 out in front, and that would work as well. All right, and then the last part is how do I get rid of this y to the negative 2? There's a couple ways to do it. I want you to think of what it means. What does that mean? It means y to the negative 2 is 1 over y squared. And then I can put this all over 1, and if I flip to the left side, I can flip the right side. And then the last part is how do we get rid of a square? Take the square root of both sides, and anytime we do that, we get a plus minus. And I do want you to know there are many, many algebraic ways to write your answers. So whichever way you write it, as long as it's algebraically equivalent, you're good. You don't get any extra points for simplifying algebraically. All right, let's look at another one and see if you're getting the hang of this. At any point, pause the video, try these yourselves. Notice I've got y sine squared y. So this whole piece needs to move over to the other side. And the more you get the hang of this, you don't have to show your work, right? I'm going to divide both sides by a 1 over sine squared. And that's going to be with the dx or dy. And notice the dx is going to come over here with the x. This x is in the denominator, so it has to be 1 over x. You can't just call it x. A big mistake. A lot of students do this. Okay, that's huge. That is not correct. It's 1 over x because it's in the denominator. So you need to know your location of all the variables. All right, and then this one's just a little bit tricky because if I want to take the antiderivative of each piece, I run into a little bit of sticky situation here. So this is actually a trig substitution. Remember, 1 over sine is cosecant, and then the squared is just going to stay. So I'm really just doing a trig substitution there. Nothing crazy. Tricky, yes, but nothing super crazy. So now I can think, well, whose derivative gives me cosecant squared? And that is cotangent. However, cotangent was the derivative of cotangent is negative, and we don't have the negative, so the negative would have to be put in. All right, and then since I'm just going to skip this step, but whose derivative gives me 1 over x? It's the natural log of the absolute value of x plus c. Okay. Now, I think you might have a question, and how come I didn't put a plus c on this side? You could if you wanted. It's a constant, right? But if I have a constant here and this side has a constant, then I would move a constant over here and it would group together with this one. The constant on this side might not be the same as this one, so they don't cancel out. All right, the last piece is now we got to solve for y. So I'm just going to bring that negative over here. And then how do I get, oh, I didn't do that. How do I get rid of a cotangent? Well, you could do the inverse of cotangent. And that gets y by itself. Or, remember the word arc cotangent is the same as the inverse. You might see it written this second way just so students don't get the -1 exponent thinking that's an exponent versus the inverse symbol. So either of those are acceptable. So that's how we separate the x's and y's. And once they're separated, then you integrate just like we did before. All right, what I would like you to do is pause the video. I want you to try these 4 problems. Try them on your own, and we're going to go over them. I'm going to actually put the answers up here so then you can check your work. But pause the video right now, and we'll go through them in a little bit. All right, so let's see how far you got. Some might be a little bit trickier than others. At any point, feel free to pause this video so you can get a little bit better view of the work that I did. I'm not going to go through it step by step, but I want you to check. First thing you should check is, did you separate the y correctly and the x? So is this statement correct? If it's not, all your other work then is not accurate. So double check that, and then go ahead and check your antiderivatives. Did you get the same c value? I tried to show you what I did in the steps. I separated the x and the y. I used the initial condition to find c. And then I plug c back in, and now my goal is to solve for y. So notice when I take the square root, when I have y squared again, I take the square root, I get a plus and a minus. But then in my answer, I only use the positive. And the reason why is if I look at the initial condition, when x is 4, my output has to be a positive 3. So I can't have the negative here because that doesn't meet the requirements for the domain. So that means we just have to indicate the positive value. One of the things you can always do with your answer is take x and plug it in here as 4. So 4 squared is 16, -16 plus 25 is positive 9. The square root of positive 9 is 3. So my solution works out. You can always check your answer like that. All right, let's look at number 3. So again, first step, you want to check to see that you separated the y's and x correctly. So you should get the x staying on the denominator on the right side, and then the y moving over as 1 over y. Then when you take the antiderivatives, notice they're both ln of absolute value of y, ln of absolute value of x. At this point, I'm going to plug in my initial condition. They're both x is 2 and y is 2. And then I'm going to simplify, which tells me c equals 0. And then I plug c back in, and then we got to solve. And in this case, I'm going to do the natural log of both sides. That reduces out ln, and I have e to the ln, which gives me the absolute value of y equals the absolute value of x. But since x is positive and y is positive, I'm going to take the positive values. So that's why they're both positive. Okay. And again, go ahead and pause at any point to double check your work carefully. So let's look at number 5. Number 5 is kind of tricky. First thing you do not want to do not FOIL. When you FOIL, you mix your x's and y's together. So notice, let's check our work here. First step, what do? We isolate the y values and bring it over. So I'm going to actually move the y plus 5 over with division, and then the x plus 2 is going to stay. Now what that allows us to do is take the antiderivative of each piece. And the antiderivative of 1 over y, I did not do that, but you could do u substitution here and let u equal y plus 5, and then you can simplify. But the antiderivative is the natural log of y plus 5. And then over here, it's just finding the antiderivative of each piece. At this point, I plug in my initial conditions, which the initial conditions were 0 and 1. So that's the blue parts. And notice there's 2 spots for x, so I put in 0 in both, and then I algebraically solve, and I get c. So I replace what c is equal to back from the original spot where I first saw c, and then I'm going to solve. So I'm going to take e, the power of e to both sides. And you could do some simplification here, but again, my goal is to get y by itself. So I noticed that e to this whole piece, e is always a positive number. And when I subtract the 5 over, my answer is still going to be a positive value at 1, because this whole mess when x is 0 is 6. 6 minus 5 is 1. So I use the initial condition to check my final answer as well. All right, again, pause this, double check your work. Last one, number 8. This one requires a pre-calc. Well, not really. It's a property of exponents you got to be careful with. So here's the first thing that makes this problem challenging. When I have e to the power of x minus y, we want to rewrite that so it's the same base, but now we're dividing e to the x over e to the y. What that allows us to do is separate the x's and y's together. So now I'm going to times by e to the y over to the other side. Notice my y's are with dy, my x's are with dx. Then the antiderivatives are actually really friendly, right? Antiderivative of e to the y is itself. Same thing with e to the x. So then I'll plug in my initial condition, simplify. Remember, e to the 0 is 1. I'm not going to grab a calculator. I'm going to leave this as e to the 2 minus 1. Do not use a calculator here to get decimal answers. All right, you could see why when you check your work. But now that I know c, I'm going to go back to where c was first present, and we're going to plug in what c is equal to. And then my last step is to get rid of the base e by doing the natural log of both sides. And I didn't simplify it all. I'm just going to leave it just like that. All right, so there's 4 different problems for you guys to just kind of analyze and look at. And I want to just show you this really quick. Don't write this down, but it's just important to note that there is this idea of discontinuity with some initial value problems. So if a solution curve is continuous, the initial condition pins down the solution on that entire domain. So it's just for that portion if it's continuous. But if the solution curve is discontinuous, the initial condition only pins down the continuous piece of the curve that passes through the given point. The domain of the solution must be specified. Good news, I haven't seen a lot of that on the AP test, but that's not to say that it's not there. So let me show you one quick example on how this works, and we'll view it from a graph so you can just see what works. Find the particular solution to the equation dy dx, and here's the equation. Well, what I'm going to do first is I'm going to separate. There are no y's, so this is just a really friendly problem for us now, because we don't have to separate the x's from y's. I'm just going to bring the dx over, and I'm going to write my equation. Antiderivative of dy is y, the antiderivative of 2x is x squared, and the antiderivative of secant squared is tangent to x plus c. And we're going to use the initial condition. Well, tangent of 0 is 0, so that means c is my value. Take my answer. We're going to put 3 in for c. Right. Now, what happens when I graph this? That's the important part. So now, what if I graph this? And the only way you would know that what this graph looks like is if you use Desmos or grab your calculator. When you graph it, it's going to look like this. Now notice, our initial condition, what was the initial condition? 0, 3. So what if I go over 0 up 3? There's my initial condition. And what it means is that the only solution that my answer is going to be true for is the one that contains this point. So from here to here. Now, if we were graphing this by hand, we would notice that this value right here, there's an asymptote here. And this is at 1.57, which you might not recognize it. There's an asymptote here as well, and that's at negative pi over 2. So all this is saying is that just be aware that your domain is going to be your answer. Yeah, I should say your answer here with this initial condition at plus 3 is specific only for this domain. It doesn't include the other parts of these graphs. So this equation is not true for these other points. It's only true for the blue piece. So take that for what it's worth. You might see it come up, but I haven't seen a lot of that. All right, homework tonight is 7.2 day 1 in the textbook, page 551, and the following problems. The worked out solutions are posted in Schoology. If you get stuck, please use that as a reference and continue to check your answers. Have a great day. I will see you next week for sure.